Hello my dear students, this is Hina Kausar, lecturer in physics from Don Bosco PU College, and let us start our physics classes of class 12. So very firstly we will begin with our very first chapter, that is electric charges and fields. So in this chapter we are going to cover all these topics, that is electric charge, properties of electric charges, Coulomb's law, electric field, electric dipole, electric flux, Gauss law and its applications. So let us begin. All of us have the experience of seeing a spark or hearing a crackle while taking off the clothes, especially a synthetic cloth during summer. Or you might also have experienced an electric shock while holding the door of a car, or a very simple example I can say is thunder lightning you might have seen, right? And also you might have experienced while combing your hairs, you might have experienced a shock, or after combing the hairs, if you bring that comb near a small bits of paper, it gets attracted, right? All these examples, all these experiences are due to the discharge of electric charges. Now this discharge of electric charges will lead to a static electricity which will be experienced just for an instant of time. I mean to say just for a moment you can experience an electricity. Right. In this chapter we are going to deal with this static electricity, which means you are going to study the part of physics called as electrostatics, which deals with the study of charges which are at rest, which means they are not moving. The force between the static charges, the fields and the potentials due to these charges which are at rest. All these phenomena we are going to learn under this chapter. Right? Static means nothing but it is not movable, not moving with respect to the time. The key point in this whole chapter is about electric charges which are at rest. So, let us try to understand what are these electric charges, how they originated, and what are the properties of electric charges. Right? So, around 600 BC in Greece, there was a scientist called Thales. He observed amber. Amber means it's a plant resin, basically. So, when it was rubbed over wool or silk cloth, he observed that it attracts light objects. And the word amber, which means in Greek, its meaning is electron. So the name electricity was originated from there, right? Similar experiments and efforts were made by many different scientists to analyze what are these electrical charges are. So let us try to see and understand one such experiment which was conducted by Williams. So in his experiment, what he did, he considered two glass rods. And when he brought these two glass rods near to each other, obviously since it is electrically neutral, those two glass rods neither attracted and nor repelled. And the same two glass rods, what he did, he rubbed it over silk. When he rubbed it over silk, the glass got electrified. Electrified means it got charged. So when again he brought those glass rods near to each other, it started showing the force of repulsion. So in the next attempt, what he did, he considered two plastic rods. And again, obviously since they are electrically neutral, when he brought it near, neither they attracted and nor they repelled. So the same two plastic rods, he rubbed it over fur. Fur means animal fur. Say for example cat fur. Okay. When he rubbed it over the fur, the plastic rods got electrified, which means it got charged. As soon as it got charged, and now again when he brought those two plastic rods near to each other, those two rods again showed the force of repulsion. right? Similarly, in his next attempt, what he did, he considered the plastic rod which was rubbed over the fur and also the glass rod which was rubbed over the silk cloth, right? Now in this attempt, he brought near this plastic rod and glass rod. What he observed? He observed that there is a force of attraction between those two rods, that is the plastic rod and the glass rod. And again, one more attempt he did. What he did? He considered the plastic rod and the fur which he had used to rub over it. Now when he brought one of the plastic rod near to the fur, those two things got attracted. Similarly, the glass rod which he had rubbed over the silk cloth, when he brought it near, again these two materials showed the force of attraction. Now, from all these experiments, from the first experiment, second and the third, what one can infer? So what we can infer from these experiment is that we can define these electric charge. How we can define? Whenever two different materials are electrified, are charged, then those two materials will exhibit electrostatic force of either attraction or repulsion. This is how we define an electric charge. Electric charge is the fundamental property of all forms of matter that exhibit electrostatic force of attraction or repulsion in the presence of other matter. And how do we measure these electric charges? We usually measure it by Coulomb, which is denoted by the letter capital C. And by convention, we have considered there are two kinds of charges. Since we have observed two types of forces, right? That is force of attraction and force of repulsion. So because of that, we had conventionally mentioned that the positive charge is possessed by a proton, which is denoted by the letter plus, and the negative charge is possessed by the electron, which is denoted by the letter minus. And the value of this charge particle is 1.6 into 10 to the power of minus 19. So by convention, there are basically two types of charges. A proton, which is possessed by positive charge and which is denoted by plus E, and an electron which is possess an equal negative charge which is denoted by minus E. And the value of this charge, the basic fundamental charge, is equals to 1.6 into 10 to the power of minus 19 Coulomb. And the property which can differentiate these two charges, that is from positive and negative, or in simple words, the plus sign and the minus sign is called as the polarity of the charge. Now let us try to understand how or when do we say the body is got positively charged, or when do we say a body is got negatively charged, right? To understand this, let us consider a matter. Since matter is very extended object, I'll consider the very fundamental unit, that is nothing but an atom. And since the lithium is the smallest element, I'll consider, since it is simple and smallest, I'll consider this element which is having atomic number 3. All of you know that an atom is basically made up of a central nucleus which is possessed by protons and neutrons together, and the electrons will be revolving in different orbits around this nucleus, right? Since the lithium atom is having 3 protons, it will have equal amount of 3 electrons revolving around it. If the number of protons are equal to the number of electrons, it means the number of positive charges will be equal to the negative charge. Since in this lithium atom, the number of protons, that is number 3, is equal to the number of electrons, the 3 electrons, it is electrically neutral because the positive charges which is possessed by the protons will cancel the negative charges which is possessed by the electron. So on the whole, this atom will be electrically neutral since it is carrying zero net charge. Positive charge has cancelled the negative charges. Now, when do we say this neutral atom has been electrically charged? Whether it is positively charged or negatively charged, let us see that. In this example, as you can see, the same lithium atom which was neutral of having 3 protons and 3 electrons, the outermost electron which was free electron, that free electron, since it is loosely bound with the central nucleus, it may be easily come out of the atom when it is rubbed over another matter, right? So then what happens? The number of protons will remain same, that is 3, but the number of electrons which was 3 prior, now it has decreased to 2 since the loosely bound electron has been discharged to another matter, right? Now what about the total charge present in this atom? The number of protons is 3, whereas the number of electrons is -2. Therefore, the total charge in this atom will be +1, which means this atom now has got positively charged, right? Now let us see one more example. Say suppose for example, in the neutral atom of lithium, which is having 3 protons in the nucleus and 3 electrons which are revolving around the nucleus. Now if a free electron from another material enters into this outermost orbit, then the number of electrons in this neutral atom increases, right? So the number of protons will be 3 plus, number of electrons now it is 4 minus, right? So the total charge on this atom will be negative because the negative charge in this atom has been increased by one number, right? So whenever a neutral atom gains an electron from an external source, then that atom is considered as negatively charged atom, right? The same example we can extend it to a body or an object. Whenever an object or a body gains electrons, so the same concept we can extend it to an extended object or a body, right? So whenever a body or an object gains electrons from an external source, then that body or object will be considered as negatively charged object, right? If the same body or an object loses electron from itself, then that body becomes positively charged because the number of positive charges in that body has been increased, right? Now after understanding this, how the body gets positively charged or how the body gets negatively charged, now we can understand these experiments even more precisely, right? In the previous example, as I had said earlier, you had seen these 2 glass rods had been rubbed over silk cloth. What happened during this process? The electrons which were loosely bound to this glass rod, it got transferred to this material, that is silk. Thus, the glass rod becomes positively charged because it has lost the electrons, the loosely bound electrons, and transferred it to the silk, right? Similarly, in the next experiment, what we observed, the plastic rods, when they were rubbed over the fur, right, the electrons might be tightly bound in this plastic material, because of which the loosely bound electrons of this fur got transferred to this plastic, and because of which, since the electrons of this fur has entered the plastic rods become negatively charged. Since both the plastic rods has got negatively charged, therefore it showed the force of repulsion, right? And in this experiment, what we observed, the plastic rod which was already negatively charged, right, after rubbing it over the fur, and the glass rod which was positively charged after rubbing it over the glass rod. Obviously, when 2 different types of charges were brought near, it will show a force of attraction, right? And since
In this example, the fur had lost its electrons and transferred it to the plastic rod. The fur obviously became positively charged. It has lost the electrons. Therefore, it got attracted to the plastic rod. In the same way, the glass rod, since it had got positive charge, which means it has lost the electrons and it transferred it to the silk cloth, the silk cloth became negatively charged since it gained the electrons. Since both these objects are having two different types of charges, again it showed the force of attraction, right? Now I guess it is clear to you that whenever two different charges, right, or two different charged objects are brought near, it will show force of attraction, and if the same type of charges or same charged bodies are brought near, it will show force of repulsion. And also whenever the electrons, right, in short you can by this picture you can understand that whenever a neutral body loses the electrons, it becomes positively charged, and whenever it gains electrons, it becomes negatively charged, right? So let's have a quick review on the things which we have learnt in this class. We understood what is an electric charge. Electric charge is a fundamental property by which any material can possess electrostatic force of attraction or repulsion towards another matter, right? And also we understood there are two types of charges. One is positively charged, which is possessed by proton, and the other one is negatively charged particle, that is electron, right? And the SI unit of charge is coulomb.
Now, let us try to understand what are the basic properties of electric charges. The very first and foremost is, as I said earlier, there exist only two types of charges, that is namely a positive charge and a negative charge. And this name given to the charge is by a American scientist, that is Benjamin Franklin. Conventionally, he just gave that name as positive charge and the negative charge. This is one of the characteristics of the charges. And the second one, as we seen in the previous examples, that is like charges. Like charges means the charges which are having the same polarity or the same signs. Say for example, plus sign or minus sign. So these same types of charges or the like charges will always show force of repulsion, or they will repel each other. Whereas the charges which are having different signs or different polarities, that is positive sign and a negative sign, will show force of attraction, or they will attract each other. You should always remember this very basic property of this electric charge. Fine. The next important characteristic of this electric charge is it's a scalar quantity. As you know, what is a scalar quantity? A scalar quantity means which has only magnitude and not a direction, right? So a charge is said to be a scalar quantity. Why? Because it has magnitude and it can be added algebraically with simple algebra, right? For example,
let us consider an example to understand how a charge can be considered as a scalar quantity, right? Let us consider a system consisting of 2-point charges. Usually, a point charge is denoted by the letter small q. So here I am denoting it as Q1 and Q2, right? Then if I have to calculate the total charge of this system, then what I'll do, I'll simply add these two quantities, just like real numbers, right? How do we add real numbers? Like 1 plus 2 plus 3 plus so on, right? Similarly, we can add these point charges as Q1 plus Q2 plus Q3, so on. Since we are adding these electrical charges just like the real numbers, just like the scalars, therefore, we can consider an electric charge as a scalar quantity, right? And this electric charge can also be considered in different units, right? First, as I had said you earlier, the SI unit of charge is coulomb, right? Other practical units which we usually use are one electrostatic unit, that is ESU, whose value will be equal to 1 divided by 3 into 10 to the power of 9 coulomb, And also one more unit is one electromagnetic unit, EMU, right? So its value will be equal to 10 coulomb. And this electric charge is a derived physical quantity, right? It's not a fundamental one, it's a derived physical quantity, and its dimensional formula will be considered as capital A and capital T. Capital A refers to ampere and capital T refers to the time, right? So next important characteristic of this electric charge is additivity of charges. What do I mean by saying additivity of charges? It means the electric charges can be added with the simple algebraic sum, right? The charges can be added just like real numbers with a simple algebra. Say for example, just as I mentioned, if you consider 2-point charges Q1 and Q2, then the total charge will be equal to Q1 plus Q2. If you consider n number of charges in the system, then the total charge will be considered as Q1 plus Q2 plus Q3 plus so on up to plus Qn. But the very important thing which you have to note here is whenever we are adding charges, right, even when it is a simple algebraic sum, we have to consider the sign of the electric charges, because electric charges has two polarities, right, a positive polarity and the negative polarity. So whenever we are adding charges, we should consider these signs or these polarities. Just I have shown here one example, right. Say suppose for example there are charges of plus 1 coulomb, plus 2 coulomb, minus 3 coulomb, plus 4 coulomb and minus 5 coulomb, right. Then the total charge will be plus 1 coulomb, plus 2 coulomb, plus minus 3 coulomb, plus 4 coulomb, plus minus 5 coulomb, right. So the total sum becomes this plus 3 and minus 3 gets cancelled, plus 4 minus 5 becomes minus 1 charge. So the net charge or the total charge of that system will be minus 1 coulomb, right. You cannot compare this total charge, although the charges can be similar to the masses, right. Mass of a body can be added just like real numbers, 1 kg plus 2 kg plus 3 kg, but the magnitude of the mass will be always positive, right. But whereas in case of charges, although charges can be added just like real numbers as masses, but here it's very important to consider the polarity of the charges, that is the sign of the charges. Fine. So this is about additivity of the charges. So the next very important characteristic of the charge is the quantization of charge. What does this mean? It means any electrical charge is said to be quantized in nature. It means there is a smallest amount of charge and all other charges will be integral multiple of this smallest unit, right. Say for example, that is Q is equals to plus or minus Ne. This E will be the smallest unit, that is the fundamental unit, right. Its value will be 1.6 into 10 to the power of minus 19 coulomb. So all other charges, any charge which you consider, will be the integral multiple of this fundamental unit, where n is the integer, right. So it can take values of 1, 2, 3. What does this mean? If you consider any system, right, the charge will exist in it in a discrete packet, not like continuous, not like continuously like 1 coulomb, 1.5, 1.3, 2.5. Charge will not exist in that manner, right. Then how does it appear? It will always exist in discrete packets. Just in this example you can see, right, since according to the quantization principle, charge will be always the integral multiple of this basic unit. So charge can always take the values as, when you go on giving the values for this n integer, that is 1e, 2e, 3e, ne, right, so on up to ne. So the charge value will be Q is equals to 1 into 1.6 into 10 to the power of minus 19 coulomb, because this the value of the basic unit 1.6 into 10 to the power of minus 19 coulomb, right. So the next charge value which can exist in nature will be 2 into 1.6 into 10 to the power of minus 19 coulomb, right? And the next existing charge will be 3 into 10, 1.6 into 10 to the power of minus 19 coulomb, right? What does this infer? It means in nature, there will be no fractional values of the charges. For example, there will be no 2.5 charge, right? Why? Because we have already mentioned, if charge has to exist, it should be always an integral multiple of the basic unit of the charge. It cannot be in between values of these discrete packets, right? In simple words, you should always remember that quantization of charge, it means the charge exists only in the integral multiples of this fundamental unit or the basic charge. Q is equals to plus or minus NE. Fine. So this is about charge being quantized. Okay. Next thing is charge is conserved. What do they mean by charge is conserved? According to this, what it states that the algebraic sum of positive and negative charges in any isolated system always remains constant. In any system, right, the total number of positive charges will be equal to negative charges. In simple terms, you can say charges can neither be created and nor be destroyed. It can get transferred from one body to another body. Say for example, in the previous examples we had seen the glass rod has been rubbed to silk, right? What happened in that case? The negative charges on the glass rod, it got transferred to the silk, right? And the silk got negatively charged, whereas glass rod got positively charged. But the net charges of the whole system, glass rod plus silk, that net charge will remain same, right? It remains 0. When you take this both together, it will be electrically neutral because the total number of positive charges present in the glass rod will be equal to the total number of negative charges present in the silk. Isn't it? In the same manner, if I quote one more example, a nuclear fission reaction, right? If you consider a reaction, the number of protons before the fission will be equal to the number of total protons after the fission, which means the total number of charges before the reaction will be equal to the number of charges after the reaction. So on the whole, during this process, what happened? You observe that the total number of charges will remain same. So the total initial charge will always be equal to total final charge, right? So this means the charges in nature are always conserved in nature. Fine. And the next important characteristic is charge cannot exist without mass, but mass can exist without charge. What does this mean? See, whenever I say a body is getting charged, say suppose if I am telling a body is getting negatively charged, what happens during that process? The electrons will get added or gained by that body. Only then the body will get negatively charged, right? Since the electrons are being accumulated on that body, the body will slightly change in its mass because obviously electrons have certain mass, right? Similarly, if I say a body is getting positively charged, which means it is losing electrons. If it is losing electrons, since electrons will have a small mass, obviously we will observe a slight decrease in the mass of the charged body, which means whenever a body is getting charged, right? Whenever we are saying that a body is accumulating charges, definitely there is a change in mass. But whereas the vice versa is not true, it means mass will not be dependent on charge. The mass can exist even if there is no charge, right? A neutral body, of course, it will have mass, right? So this is how we can relate mass and the charges, right? Now, one more important characteristic of electric charge is it is relativistically invariant. What does it mean? It means the charge of any body will not be dependent on the speed of that body or the motion of the body. Say for example, if a body is carrying 5 coulomb of charge when it is at rest, okay, and when it is moving, say suppose it is moving with certain speed of 50 km per hour, right? In that case also the charge will remain same, that is 5 coulomb, right? Irrespective of the frame of reference, you can say the charge value will remain same. The charge value at rest will be equal to the charge when it is in motion. So in short, we say that charge is invariant. So far these are the important characteristics of the electric charges. So just to have a quick review, let us recall it. Very first one is charges are having, there are two types of charges. One is positive charge and the negative charge, and the like charges will always repel each other and the unlike charges will attract each other. The third characteristic is charge is a scalar quantity. The fourth characteristic is additivity of charges, right? And the fifth one is quantization of charge, which means charge will always exist in discrete packets, that is the integral multiples of fundamental unit of the charge, right? And charge is always conserved, right? It means the total number of charges initially will remain same after the completion of the process, right? Which means charge in any system will always remains constant. And the last properties are the charges. Whenever a body gets charges, the mass of the body will change, right? And whenever the body get discharged, the mass of the body will also decreases, right? And the last characteristic is charge is invariant. Irrespective of any frame of reference, charge value will never change with respect to its motion. Whether it is at rest or motion, the charge value will remain same. So these are the important characteristics of electric charge. Now since we have understood what is an electric charge, what characteristic it possesses, right? Now let us try to understand how we can detect these electric charges in any body, right? So there is a very simple instrument called as gold leaf electroscope. What is, so let us consider the construction of gold leaf electroscope. Let us see how it is constructed and how it works to detect the presence of electric charge. So it's a very simple apparatus. It basically consists of a metallic insulated metal rod. Here it is insulated, fine. And this insulated metal rod, one end of this insulated metal rod will be connected to gold leaves, right? Two gold leaves will be connected in this manner, and the other end of this metal rod will be connected to a metal disc, fine. And this whole apparatus will be kept inside a glass jar, evacuated glass jar, so that no air disturbance should happen during the process, fine. So this is a simple setup of an gold leaf electroscope. Now how does it work, right? So say suppose for example, if we consider an uncharged body or a neutral body which is not possessing any charges and touch it to the metal disc, obviously it will not show any divergence in the gold leaves, right? Because the body is electrically neutral, it will not flow any electric charges. But for the same apparatus, if we bring a charged rod, say suppose the glass rod has been rubbed to silk and it has got electrically charged and connected to the metal rod, then what happens? As soon as you touch this charged body to this metal disc, the charges which are accumulated on this rod will pass on to this disc, and hence these gold leaves, it will get diverged, right? Because these two leaves will acquire the same charges which is having by this rod. Say suppose this glass rod is having positive charge, then this metal rod through this metallic disc, through this metal rod, the charges will pass on to both the leaves, right? And hence it will get diverged like this, due to the force of repulsion between these two foils, right? So similarly, what happens then? Since the divergence, when we see the divergence of this gold leaf, one can infer, what we can conclude by this, it means this body which we have just touched to this metal disc is being charged. We can understood that, right? Hence we can detect the presence of charge on this body. So this is how we can detect the charges, right? The amount of divergence in this gold leaves will tell us the amount of charges being accumulated on this body, whether the charges are present on the body or whether it is absent. If there is no charges, then there is no divergence in the gold leaves. If the charges are more, then the angle of divergence will be more. This is how we can detect the charges on any body by using a gold leaf electroscope. Fine. So this is in short, you can understand here, whenever a charged body is brought near the metallic disc, the leaves will get separated. This shows the presence of electric charges on the rod, and if the charged body is removed, then what happens? The angle of divergence will release and it will come to rest, right? So this is a simple apparatus used to detect the presence of electric charge on any body. So this is all about today's class. Let's quickly review everything what we all have learned today, right? We understood what is an electric charge. Electric charge is a basic fundamental property by which a matter can exist electrostatic force of attraction or repulsion on any other matter, right? And there are basically two types of charges. One is positive charge and negative charge. And the SI unit of charge is coulomb, right? And different properties as well we had discussed. That is, charge is a scalar quantity, right? And additivity of charges we learned, quantization of charge, and charges are conserved, right? So all those basic properties we understood. And finally, we understood a simple apparatus which can be used to detect the presence of electric charges on any body, that is a gold leaf electroscope. So this is about today's class. I hope you liked the video. In the next class, we will continue the same concept.